It's no secret that I'm a big fan of chiptunes, and the SID chip in the Commodore 64 is legendary for them. I love a good curiosity experiment, so I was wondering, can we turn this into a fully automated jukebox? Turns out there are several different ways, so let's have a look at 3 of them right now in episode 100 of Retro Bits. This is my Evo 64 that I built in a previous episode. With its stereo SIDs, Korg NewTube preamp, and VIC-2 Kawari, it's the perfect platform to start from as we test out various ways to implement a hands-free, self-playing jukebox. If, like me, you were in North America and listening to SID tunes on your C64 in the 80s and 90s, you're probably already familiar with Compute's Gazette MUS format and the stereo SID player by Mark Dickinson. For a complete history on the evolution of stereo SIDs, as well as the editor and player, check out the episode linked above. The software only seems to work properly on NTSC hardware, so that's what I'm using right now. The best resource today for this format is CGSC, the Compute's Gazette SID collection, which indexes over 16,000 songs along with over 4,000 tracks in stereo. The archive contains a variety of resources, including disk images for the stereo player, along with other tools. Songs are sorted by artist, so you can pick and choose your favorite tracks and create your own disk images. There's a separate download available that bundles all of the music into individual D81 images, which is convenient if you're using an emulator or real hardware with a modern SD card-based storage device. Speaking of which, we want to have access to a lot of songs at once for our jukebox, so let's try the stereo player with an II IEC, using the device's native partition like it's a big hard drive. First, I'll grab a copy of the latest stereo player from the disk images provided in the CGSC archive. I'm using Durmaster on my PC, which I consider to be essential software for any C64 enthusiast. All I need is the single large program file, so I'll copy that to a directory on my SD card. Now I can copy over a selection of MUS files, along with any associated lyric, picture, or stereo files to go with them. In testing, I found the maximum number of files the player will read from a single directory is 220. You can have more, but they'll be ignored. Rename the files so everything is in lowercase and remove any special characters. This will make them easier to read and type on the Commodore. Also, you can safely remove the .prg extension from the stereo player if you want. It makes no difference, but it will be displayed as part of the file name if you don't. Alright, I think we're ready to give this thing a try. Using the SD2 IEC, I've navigated into the directory I created and launched the player. It seems to have no problem reading the files from the native partition, no disk image required. Nice! Now here's one thing I found out the hard way. In the configuration screen, there's an option for software fast load, and it's always enabled by default. If you don't go in and turn it off, this is what happens when you try and load a song. With the fast load turned off, we're ready to rock and roll. We can tag individual songs to play with the return key and hit F2, or we can just hit F3 to play every one of the files in the directory sequentially. I don't see a way to randomize the selection, although we can enable repeat with F4. Ready? Here we go! Now, one thing to keep in mind is that this format is very much a product of its time. The songs are representative of the state of the art in the late 80s and early 90s, but SID music continued to evolve over the next 30 years, as we'll see shortly. So, what I'm trying to say is, be kind. we could just let each song play to the end and automatically move to the next track in the playlist, but hitting spacebar allows us to skip ahead right away. Which, if I'm honest, I found myself doing a lot here. And no stereo player demonstration is complete without at least one track from Jerry Roth, aka Dr. J. Now let's try the same thing, but with the Soft IEC mass storage device that's part of the Ultimate 64 and 1541 Ultimate 2 Plus. Drive A and B are already disabled, so I'll turn on the IEC drive as device number 8. Now I can navigate to the directory on my USB stick where I've loaded the player and music files. From the F5 menu, I'll set this location to be the root of the Soft IEC drive. A quick directory listing shows that it's working, so I'll launch the player. So far so good, but then this happens when the player tries to enumerate the files on the disk. I made sure that the files are named properly, set their type to program instead of sequential, and disabled the fast load routines, but nothing I did got me past this screen. I have no choice but to conclude that the stereo player doesn't work with the Soft IEC drive in its current form. Good news though, it works perfectly fine with an emulated 1581, and we already have all of those disk images provided to us by CGSC. We can also make our own with Durmaster, as I've demonstrated here. Adding files is as easy as dragging them into the window and renaming them. A single 1581 disk can hold up to 296 files per directory, and I'm already running up against that limit with plenty of free space left. With the Soft IEC drive turned off, I'll mount the D81 image I just created. I have 296 songs on this disk, but as I mentioned earlier, only the first 220 get loaded by the player. The emulated 1581 drive is scorchingly fast with Jiffy DOS enabled, so this is a great option for those who want to use the stereo player with an Ultimate device. Now it's time to move on to the next solution and look at something a bit more modern. If you were a European 64 user back in the day, or listened to modern compositions, chances are that you've used the .sid file format instead. And the most popular player for these files is SidPlay64. Inside the archive are versions of the player for a wide variety of hardware devices. There are builds for the Ultimate 2 Plus as well as the SD2 IEC, including a separate version for systems with a RAM expansion unit or REU. The non-REU player can only load up to 164 file names at a time, but can access additional blocks of files using the clear home key. The REU version, on the other hand, can handle up to 65,000 files at once. Of course, a normal version is provided for use with regular floppy drives as well. The software's author also provides a download link to a curated list of just over 1,000 of his favorite SID tracks, which we can use to test out the player. Similar to the Compute's Gazette music system, there's an archive of SID tunes called the High Voltage SID Collection, or HVSC. It currently catalogs over 58,000 tracks. Unlike the old .mus format, .sid files are still heavily used to this day, so we can find both modern and classic compositions here. Inside the archive, we can find tracks extracted from demo scene productions, games, and also sorted by artist. Between these two archives, I think we should have enough content for our jukebox, so let's get to testing. Now, most tracks in the .SID format were developed for PAL systems and will play too fast on NTSC hardware. While the player will run fine on either, we're going to want accurate timing for what comes next, so I'm going to switch the Kawari in my Evo 64 over to a PAL model of VIC-2. There's a SID Play 64 version that's made specifically for the 1541 Ultimate 2 Plus, so let's try that out and see if the device can redeem itself. With this version, we don't need any emulated drives. Heck, we don't even need the IEC cable to be connected at all. We will have to ensure that the Ultimate Command Interface is enabled. This is an API that gives the 64 direct access to the Ultimate hardware, including attached USB storage devices. Now we can launch SID Play 64 directly from the USB drive's file system. This Evo 64 has a second SID at address D420, so I'll answer the questions accordingly. Files that use play address 0000 will prevent playlists and shuffle play from working, so we want to answer yes here. We'll talk about modded SID files in a moment, so let's skip past this option for now. Once we're at the main menu, we can navigate through all the Ultimate's attached storage thanks to SID Play 64's use of the command interface. Let me drill down into the location where I've loaded the music files. And there it goes, loading all 1095 file names into the REU. Now all we have to do is select a song and hit return to play it. Notice that it says the track is 3 minutes and 5 seconds long. Let's try another song. Huh, same as before. Maybe it's a coincidence. Okay, what the heck is going on here? Well, .SID files are basically just program code being executed on bare metal, and the player doesn't know anything about how long they're supposed to be. Since we can't detect the length of each song, our jukebox won't be very good, will it? Well, not so fast. SID Play 64 has a special feature that allows you to modify SID files by injecting them with timing data that comes from a song-length database that's part of the high-voltage SID collection. We can modify files in bulk with this program here, but as luck would have it, the curated playlist we downloaded earlier has a directory that contains files that have already been modified. Two caveats. First, modified files won't work with other SID players. And second, the process won't work with stereo SIDs, which is a bummer. We'll look at a solution for this in a moment, but for now, back to testing. Ah, that's better. Now that we have proper song lengths, we can turn on our jukebox. This M stands for manual, and it will keep playing the same song until we select something else. Hitting M on the keyboard will change the mode to play the next song in the directory when the timer counts down to 0. R is for random, and it does exactly what you think. If we don't want to wait, hitting X will immediately jump to the next track. Yep, random play is working. With this, we now have a SID jukebox that can play literally tens of thousands of songs completely unattended. Let's see what happens when the timer runs down. Well, it works, but that was abrupt. Many songs are designed to loop indefinitely and don't actually have a well-defined endpoint. Also, if you're playing a PAL track on an NTSC system, the countdown may not be accurate. What I've demonstrated here will also work on an SD2 IEC, Turbo Chameleon, CMD hard drive, anything that can mount a disk image, or even a real floppy drive. What I really want is to be able to play stereo SID files unattended, so let's see how we might go about solving that problem now. In a recent livestream, I demonstrated the new REST API that was added in the latest firmware to the Ultimate 64 and 2 Plus. REST is a stateless interface implemented through HTTP and is commonly used when building scalable microservices for web applications. With it, we can control various aspects of the Commodore, including uploading and playing SID files directly from another device. Let's see if we can take advantage of this capability to automate playing of the stereo SID files that can't be modified with song length data. Alright, so this is what I've come up with, and it's a very basic Python script that's really just a proof of concept about how we could implement a jukebox using the REST API. Now, I'm not a Python programmer. I could do this much easier in Perl or even Bash, but I figured it would be a good opportunity to learn something new. So here we've got the requests module. This is the only thing I had to install to make this work. Everything else is kind of a built-in to Python, but this is how we're going to talk to the REST API on the Commodore. A few configuration items down here, including the IP address of your Ultimate 64 or U2 Plus. Down here, we have the full path on disk to the HVSC, the high voltage SID collection, wherever you happen to have unzipped the archive on your local machine. Next, we have a playlist file, and this is just a basic text file that describes the songs we want to play with our jukebox. Inside the file, we have about a dozen of my favorite stereo SIDs from the high voltage SID collection with their full path and file name. And we're going to iterate through all of these files with our jukebox. That's it for the configuration. Next up, we have a few variables that we're setting, and then we're going to load in the playlist and we're going to randomize it. Now for each of the files in the playlist, we're going to iterate through them one at a time, and we're going to generate an MD5 hash of the file that we're working on at this moment. And the reason for that is because we're going to use the high voltage SID collection song length database to determine how long each of the songs we're playing is. And if we look at that file, here we can see that each file in the HVSC is indexed, and it has an MD5 hash of the binary object, as well as a timestamp. That's minutes, seconds, and microseconds. And so we can use this to extract the time code for each of the files that we have in our playlist. So we're going to do just that, and we're going to use a regular expression to perform a substring match on the number of digits separated by a colon here. So we're going to extract the minutes and seconds. We're going to take the minutes, multiply it by 60, add it to the seconds, and that will be our counter for this particular song. Then we're going to inform the user what we're about to do, and we're going to make the REST API call to post the file from our machine over the network to the Commodore. So we're going to upload the file to the Commodore and ask it to play it. I'm going to do some error checking here, and then we're going to start a countdown to show how many seconds are left before this song reaches the end. When we're done, we're going to say we're done with the song, and we're going to reset the Commodore 64 in order to stop playback immediately. We don't want the song to accidentally loop back to the beginning while we're uploading the next track to the Commodore. Finally, we're going to loop to the next iteration and run through every file in the randomized playlist, at which point we're done and the playlist is over. Now at the bottom, I have a whole bunch of things that we could implement to make this script better. We could have randomization as an option. We could play the entire HVSC archive. We could implement a key to fast forward to the next song, stuff like that. But again, this is just a proof of concept, so it is what it is. Now let's see how it works. Now that is what I'm talking about. The length shown by the player is wrong, but our script is right. Let's skip ahead a bit to run down the clock and make sure everything works. Perfect! Now, of course, this is just a proof of concept, and certainly not limited to just a PC. You could control your Commodore from your mobile device, tablet, or even a web app. The sky really is the limit here. These tracks are a lot more modern than the Compute's Gazette examples from the 80s. C64 music continued to evolve over the intervening decades as clever coders learned how to extract even more from the humble SID chip. The REST API isn't limited to SID files either. You could easily add cartridges, standalone programs, Amiga mod tracks, even demos that require disk changes into the rotation for a fully automated C64 showcase. I've posted this Python script up to GitHub, and a link is in the description. I hope this inspires you to mess around with the new API and maybe come up with something cool of your own. If you do, let us know in the comments, or feel free to shoot me a pull request. Now, I could play these all day, but unfortunately, we've got time constraints to observe. If you're still here, you must love SID tunes as much as me, so A+ for sticking around. Unfortunately, all good things must come to an end, and I've got to draw the line somewhere. There are simply too many amazing tracks from all these talented artists to do justice to, but I hope you enjoyed the small sample we listened to today. So there we have it, the old and the new working together in perfect harmony. Do you know another way to implement a C64 SID jukebox? Let us know in the comments. I hope you enjoyed this bit. Thank you so much for watching, and we'll see you next time on Retro Bits.